Hey, good morning, everyone. Thanks for joining in the morning. So yesterday we had a first session where we discussed about some of the basics of data warehouse, right? Transactional database. What is the difference between OLAP and OLTP?
చూస్తా 9:30 వరకు చూసి టీఎల్కి మెసేజ్ చేస్తాను.
Sorry. Yeah. So the difference between OLTP and OLAP, right? And ETL, ELT. Okay, why do we go for data warehouse? What is the significance of data warehouse? Okay, what type of data would be stored in the data warehouse? Right. So these are all the things we discussed in the yesterday session. So we continue the session today, and we'll quickly go through what are the different schema models we have in the data warehouse. What type of data would be stored in the data warehouse, right? So these are all the things we will try to focus today, right? So let us jump into the data warehouse thing. And within the data warehouse, so whenever you decide a data warehouse to be constructed, right? So usually you have two types of tables. Okay, so what is the dimensions and facts? Okay, dimension table and fact table. So we have dimension table and we have fact table. Okay, dimension table and fact table. So this facts will have all the values or measures it will have. Okay, so what is the dimension then? Yesterday, if you remember, I was talking about dimensions, subject, right? So what are the dimensions actually? Dimensions are nothing but the values or the properties with respect to what you are going to analyze the data, right? So those are called dimensions. So dimensions, they basically it will have the properties because of which or through which, with respect to which we analyze the data, right? So if you take any example, like a product example, as I was saying, right? So product is a dimension, right? So branch is a dimension, country is, location is a dimension, or if you have some brand, that is a dimension, right? So with respect to what we are going to analyze the data, because at the end of the year or end of the day, how do you measure the data? How many products has been sold? So what type of products have been sold, right? And in particular city, how many products have been sold and which brand is getting more popularity, right? And in this particular location, at what time more people are coming? I mean to say, which day more people are coming, right? Which day the revenue is more, right? So these are all the things the people can analyze based on the dimension. So that's called dimension tables. And fact table. So the name itself says that fact. What is a fact? Fact is nothing but it will have collection of the properties which you are going to analyze, right? Which you are going to analyze. So the fact can be anything. So the fact can be anything. So the fact basically it will have the properties which you need to analyze. Say suppose how much revenue, and what is the revenue? 1 second, give me a minute. Yeah. So what is the revenue and how much, how many products have been sold? Okay. How much revenue we got, and which brand got sold what? Okay. So these are all the measures. All these things will be there in the fact table. So whatever you are measuring, okay, whatever you are measuring, this revenue, sold, all those are called measures. These are called measures. Measures are nothing but the properties which you are going to analyze in the fact table. Dimensions are nothing but the properties with respect to what you are going to analyze the data, right? So that is the difference between dimension table and fact tables. And fact table will have measures, dimension table will have the properties associated with the measures. Now, based on the properties, we have three kind of schemas. Okay, the way you design your dimensions and facts, basically we have three types of different data warehousing models: star schema, Snowflake schema, fact constellation, right? So this Snowflake schema, fact constellation, it's like a just a concept, but basically when you go for actual implementation, either you go for a star schema or Snowflake schema. Extension of these two is kind of a fact constellation. So we can say so let's talk about fact constellation. Let's talk about the star schema, what all it has. A fact table in the middle connected to set of dimension table is called star schema. Okay, there will be one fact table associated with different dimension tables. It's called star schema, like because it looks like star. Okay, it looks like star. Now see, this is the fact schema. So this is the star schema. We have one fact table. This is a fact table. And these are all dimensions. Time is a dimension, branch is a dimension, item is a dimension. We have product. Suppose if your product is a dimension, location is dimension. Okay, we have 4 dimensions and we have one fact table, right? So if you see this, each and every dimension has its own key. Okay, item has item key, location has location key, branch has branch key, time has time key. Yeah. So all these are being related to the sales fact table by using primary key foreign key relationship, right? So the primary key of this, all these things are aligned and stored in the fact table, right? So this is right. Time key, item key, branch key, location key. These are all the keys. So these are all keys known as surrogate keys, right? So these are all called surrogate keys with the help of what we are going to identify and relate the dimensions and facts, right? And here unit sold, dollar sold, average sale, revenue, which we are going to analyze. So these are called measures, right? So these are all called measures. These are the keys associated with each and every dimension table. Now, this gives me a clear idea whenever I want to analyze the data. Say, suppose I want to analyze 2010 first quarter, how much revenue or what was the average sale in the location of, in the city of Hyderabad, right? What I will do? So select from the sales fact table, join the sales fact table into time table using the time key, join the sales fact table with the location key, where year equal to 2020, quarter equal to, so 2005, I told 2010, quarter equal to first quarter, city equal to Hyderabad, right? Now you see, I'm able to capture the data, whatever it is required, just by combining these tables, right? So these are all kind of aggregated data, right? Because here you don't have the data at the minute level. So whenever you store the data from actual database to here, we aggregate it, we group it and store it where based on that. Then now it's easier for me to pick up whenever I want to generate a report, right? Say, suppose I say Johnson and Johnson brand, okay, in city of Hyderabad, okay, in 2020, what was the sale? So what I will do, I'll join this, and get the value, right? So as it looks like a star schema, so this is called, as looks like a star, so this is called a star schema, where one fact table, multiple dimension tables associated with the fact table. Now, What happens sometimes? Sometimes the dimension tables keeps on increasing. The data will be very huge and it is very difficult to manage the consistency and the load, right? So at that point of time, what do? Even we will try to normalize this dimension tables. Okay, we'll try to normalize the tables. That means we will decompose, division this one table into couple of tables to manage the data, the key, one of the key value data in another table. Okay, now that's called Snowflake schema. When the dimension tables are normalized in the star schema, it's called Snowflake star schema. Now here, suppose the brand has so many types, or type has so many types, and this country, city, country has so many things, values, or city has so many values. At that point of time, I might go for another table to manage this data. Then it's called a Snowflake schema. Let's go and see the word Snowflake schema. Now see here, in the previous slide, the city has wrapped up under location, but now city has so many values. I'm feeling this kind of a adding so much load. So at that point of time, I taken out the city and maintain in another table, right? So kind of I normalized the table here. Same way here, I have different suppliers, and suppliers are more and more, and I'm getting tough to maintain the supplier, so I'll supplier. Suppose sometime the branch also, the brand also keep on increasing. I want to manage that in efficiently. I might add one more table exclusively for the brand, right? So this is how you made the table, whatever the tables are there, that will be managed separately. So these are called Snowflake schema. So if you take a snowflake, snowflake, you know, right? In the snow, if you take any flake, any like a tiny object, that's a flake. So the flake looks like with the different dimensions and all, right? Multiple things. Okay. So that is the reason it's called Snowflake schema, right? Give me 1 minute. I'm getting important call. Give me just 1 minute, please. Yeah, sorry. Uh, yes. So when you have the dimension tables are normalized, it's called Snowflake schema, right? So that is the difference between a star schema, Snowflake schema. So what is the difference? Star schema will have one fact table and dimension tables. And when the dimension tables are normalized, it's called Snowflake star schema, right? That is the difference. Now, sometimes you might have more than one fact table. Okay, so you might have more than one fact table. In that case, when you have multiple fact tables, so then it looks like a star, right? It looks like a multiple stars. So that is the reason it's called fact constellation. If you know what is constellation in the physics, astrophysics, astronomy, so when you have multiple stars, you call constellation, right? The same way as it has multiple stars, it's called a constellation. If you see here this example, let me go to this next example. Yeah, so here, if you see here, we have this fact table. So this is a 1 star and this is a 1 star, right? One fact table, again this dimension tables. So multiple stars are there. So there is a reason called fact constellation. So here, as previous example, we have sales fact table, branch, time, item, location we have. And whereas we have one more table, shipping fact table, to deal with the shipping. Okay, to know from which, for shipping, from which location to what location, how much cost happened, how many units shipped for a particular shipping, and what are the items that has been delivered, to which location is delivered, okay, who is the shipper name, and where exactly the shipper locates, the location, right? So when these kind of things are there, the multiple fact tables are there, it's called fact constellation. So we don't use the terminology actually, even like generally also we just go for the Snowflake schema or Snowflake schema, right? So there is a difference between among these three. All right.
PC, here I have a one doubt here.
Yeah, please tell me.
So if you use a Snowflake schema, you can see a more number of foreign keys, right? So in that case, the complexity getting more, right? Compared to the
Sorry, complex.
like Snowflake, if you just see the Snowflake here, the number of keys are getting increased more, right? So if you just see in a location itself, you can see location key as well as the city key.
Right. Yes.
So in that case, more number of foreign keys are adding into the table, right?
Yeah. So dimension tables will have more number of keys. So of course it will have some considerable performance issue compared to Snowflake schema, but still the people want to maintain a separate table to manage the consistency and easy maintainability. Okay, so at that point of time we go for this one. Okay, but generally, like most of the cases, we have used star schema only. Okay, but in the modern data world, in the modern data engineering or data warehousing world, so we are kind of not building, I feel, not building as per the traditional models. We are just wrapping up everything and storing, then picking up whatever is required. Yeah. So, but still, yeah. So basically, yeah, as you said, the Snowflake will have multiple keys for the dimensions because these are all kind of normalized.
But the Snowflake schema is having the more joins, so doesn't it impact on the production?
Production, you mean to say performance?
Yeah, performance.
Yeah, performance considerably when you compare with the, sorry, 1 second. Yeah. So when you compare with the star schema, there will be little overhead on the Snowflake schema, but still when you go with the actual, when you go with the actual data residing or data maintenance, it will be good. So, but definitely the performance will be a bit slower when you compare to Snowflake schema. But it is very rare we go for such thing. But when you have huge values and you want to manage into still a separate table, then you'll go for the Snowflake schema. But definitely, as these are one more level of joins are there, it will have some impact on the performance.
No.
So that's about the.
So PC, Yeah, I have one doubt. So when we suppose we have two tables, customer and order, and we are making one fact table out of it. So
Okay.
what we call that? So
When
is
we
there a different name for that? These kind of things? Yep.
no, there won't be any difference. So we have customer and what you're saying?
Customer and order,
Customer
and
and
we
order.
have a
Yeah. So
order, and
customer.
right now we are creating one join.
Yeah.
Yep.
So the customer and order, whatever you're talking about, those are kind of transactional tables. Okay. So basically, those are the
Okay.
transactional tables. Now we need to convert that into data warehouse tables. Okay. In that case, what happens, because order will have order ID, product, the quantity, the money, and all. So we will pick it up, whatever it is required for the analysis. We will aggregate it and load into the fact table. Right. And the customer wise, we just say how many customers are there for particular day and all, we load that. But at base customer, what is a granularity, we don't store that. Okay. Because when you go for a customer, it's a too much of granularity for this one, because I don't care who is the customer, right? At the end of the day, isn't it? So the tables which you're
Makes sense.
talking about are transactional tables. Those are not into data warehouse. Getting?
Okay. Yeah, I got a little bit confused. So right now, because as we are talking about the star schema and Snowflake schema, so right now this is not, this is just a transactional database which I have, and I'm creating a fact table out of it. So what we call this as then?
Which one? Sorry, I did not get. What are you saying?
So what I'm trying to say is that suppose we have two tables, customer and order, and we are creating a fact table out of it. I understand this is a transactional transactions which we have,
Right.
but is there any specific name which we call this? Like three tables, we have two dimensional table and one, or not dimensional, it's a fact. Oh, sorry, transactional table you're saying,
So the
and one
transaction,
fact table. So
no, in the transaction database, there is nothing called facts or dimensions. Those are just tables. Fact and dimensions
okay,
we use only for the data warehouse only, as I mentioned. So these are the terminology for the
okay,
data warehouse.
okay, okay, that makes sense.
Getting? Yeah. So
Yep.
1 second. I want to give some reference for you guys. 1 second. Now see here, I'll just take an example of from net, and I'll show you the difference between these two. Okay, just adventure. If you remember, if you know, usually there will be some database called AdventureWorks database. You know what is AdventureWorks database? You know, so whenever you install data warehouse, sorry, SQL Server, you have some chance of importing AdventureWorks database. Okay, it's a sample database which will be used to kind of a what do you say, for POCs or for samples. Usually we use a AdventureWorks database. Okay, so let me show you that into a table. It's too much to paste in the document. Let me put it in a Word document and show you. Okay.
PC, I can't see your screen if you're
Yes,
sharing
yes.
anything. I don't
You
know
are not
about.
sharing.
I'm not showing it. Give me a minute.
Okay.
So whenever you want to install some databases, you want to POCs, practice and all. So we have open source 2 databases. We have AdventureWorks database, that is nothing but OLAP, OLTP, and we have at the same time OLTP also for the OLTP and OLAP both will be having for AdventureWorks. So you can download and see how does it looks like. So let me share my screen and show you how does it looks that components. Start. Okay, here it is. So OLTP. So if you talk about AdventureWorks database, it's a database for storing the data transactions. Okay, so we have the product purchase, order, sales, okay, human resource. So these are all the data we'll be storing in the AdventureWorks database. So this is readily available. If you want to explore, you can explore by taking this data into your database. Okay, we have sales, okay, sales order, salesperson, the customer, okay, email address of the persons, right, the product. So what are the product properties, product category, product subcategory, right, product diversity, the location, work order. Basically to maintain your all your products data, order data, this AdventureWorks database is there, and even HR and all. Now when I convert, when I translate this into, or when I load this into a database, there will be AdventureWorks data warehouse database. Okay, AdventureWorks OLTP. This also you can download free of cost. Now see here, all those data, whatever it is there, these are all called minute level. Okay, these are called minute transactions level. Okay, but when you build a data warehouse out of it, so basically it will have the high level of data warehouse, the high level of data, the aggregated data, and see here I'll construct here the fact tables and multiple dimension tables. Now we have one dimension table called date, and here I'm calling for one product I call dimension product, okay, dimension reseller, and for fact table, fact internet sales. For internet sales I'm assigning one more fact table. Okay, now here I have for survey response I'm adding one fact table, right? So for sales quota I'm adding one fact table. So whatever the key values I want to analyze, based on that I'm adding here the fact tables and associated with different dimension tables, right? Now if you see here, this is got constructed from this particular OLTP database. Okay, so this is how the data, and if you see here multiple fact tables, multiple dimension tables, of course it is a fact constellation. Now whenever you want to generate the reports, this will be taken as a base from where the data will be generated, right? So this is how the data looks like. So that's about some of the basics of the facts, dimensions and all, right? So in the real time or in the real cases, what happens when you load the data? So this is all about the transactions, facts, dimensions and all. So let's talk about how the data will be maintained in the zones. Okay, how the data will be maintained in the zones. So let me talk about that and showcase that. Let me add one content. Yes, I have added that. Okay, so there will be set of divisions or set of zones, set of layers will be maintained in the modern data world. Okay, how the data will be there. So this is a very important concept and layers you must understand for any data engineering project. Okay. So the data will be spread across multiple sources. Okay, so once you get the data, first time you get the data and store it in a location. In this particular location, I'm going the location here. The data will be stored in the location at first hand. It's called raw zone. It's called raw zone. Raw data will be there. That means as it is, we are storing the data from sources and storing over here. It's also called bronze layer. Bronze.
PC, your screen is
PC,
What?
Yeah, it's still Word document we can see.
Oh, is it? Sorry.
No
Are
problem.
you able to see now? Yeah.
Can you please explain one more time what you have written?
Yeah.
That
So these are
one is-
all the sources, multiple sources, source 1, source 2, source 3, source 4, source 5, whatever number of sources I have. Okay. So, and this sources, I'm getting these sources at first hand, I'm storing the data in a particular location in the data lake. Okay. It's called raw zone, bronze zone. That means the data will be in the raw format, the original format. Right now, once the data is being stored in the bronze zone, we will kind of put some of the filtration. Okay, we'll kind of put some filtration or data quality checks. Okay, some data and some data refinement and all those things we'll do. Then we will load the data into next level of zone. It's also called history zone, or it's called silver zone. Silver zone, history zone, or silver zone, right? So once the data is stored into silver zone HZ layer, so we will further refine it and we aggregate it. We will take out only the data which is needed as per the end user requirement. Then we will create one more layer is called curated zone, curated zone, or analytics zone, or gold layer. Okay, bronze, silver, gold, raw zone, history zone, curated zone, or aggregated zone. So this is how the data will be maintained across different layers in any data engineering project. Okay, so when you go for the curated zone, analytical zone, this is where the data warehousing being constructed. Okay, this is where the data warehouse will be constructed. Now, what is happens when which technology will be used there for all these things? It all depends again. So in most of the cases, what do you do? The raw zone, history zone, you will maintain the Azure Data Lake Zen 2, that is nothing but a ADLS location. Okay, ADLS, we have blob and ADLS, right? So in the ADLS storage, you manage the layers, okay, across different storage accounts. Then finally, you will load the data into data warehouse. The data warehouse can be sometimes Synapse. Okay, that is Azure Data Warehouse. Sometimes this data warehouse also will be maintained in the same data lake in terms of files, in the form of files. Okay, so data warehouse also will be managed in the files. Yeah, so data warehouse also will be managed in the form of files only, right? So this is how the data will be managed across different layers in the real time. Okay, and sometimes what happens, even this also will be done. Okay, this also will be more curated and aggregated will be done. On top of it, one more layer exclusively for that, a reporting layer will be done with a more aggregations, more with more aggregation of the data in the reporting layer. Otherwise, these three are the common zones which we manage in any project. Yeah, somebody is asking some question.
Yeah,
Speak out.
we see it's a normal traditional warehouse related process, right? But here also we can see a lot of data redundancy is there in the 3 layers. So how can we mitigate that in our new Azure side?
Yeah, so there is nothing called data redundancy in the modern data. So we keep on get the data and put it across the different layers, and each layer we do some kind of refinement, aggregation, and load the data. It's the data redundancy, the data duplicacy, overloading the data is kind of a secondary thing in the modern data world, unfortunately or fortunately. Okay, so in the just randomly get all the data, whatever is required from the source, put it in the raw zone, refine it, and store the data in the data warehouse. At some point of time, so every time the raw data will be available. Here you get the data, and after some days, say suppose you feel that you missed some data in the source, then you don't need to hit the source at the time, because the raw data always preserve the source data for the particular day. Then you will get the data. Right? So data warehouse in the modern data engineering the 3 layers maintain chestam. Raw zone, history zone, curated zone. First data as it is we get and raw zone lo store chestamu. We do like refinement, data quality checks. Okay, then tarvata data quality check చేసిన తర్వాత silver లో store చేస్తాము. Then once the silver is done, then aggregate chesi based on the requirement of the data warehouse, we store the data in the data warehouse, right? So what is the data quality check? Data quality check can be anything. Data quality check ensuring that all the tables has consistency. There are not null values. Okay, if there is some discrepancy in the if any schema has null values, then there is a issue. And say suppose the data range should be, or say suppose there is a products which should be the range of 2800 value, and we check that if the product has 2800 value based on the requirement. Okay, so these are all the data quality check will perform, will refine it, and will tune it, and we store the data in the silver zone. Once it is done, pick it up and store in the gold zone. Okay, so whenever you get the data from source to raw zone, basically we use a data factory and get the data, right? And whenever you refine the data from here to here, here to here, we do multiple things, right? We use usually ADB Databricks we use. Okay, Azure Databricks, using Azure Databricks we get the data from here to here, from here to here. But at the end of the day, all these layers, the series of transformations will be wrapped up under single data factory only.
Here I have one question. We will store the raw data in ADLS, and
Right.
then after there is a silver environment. So silver environment is what? I mean,
Same ADLS only. This is also same ADLS. So there will be one storage account, or within the one storage account, we might manage different containers, or we might go for a different storage account itself. I will talk about what exactly storage account. I'm just giving high level explanation over here. But here ADLS only will use.
okay, just we will keep the different names, right?
Yeah, of course.
Okay.
The naming of the zones and all will be different. And these naming conventions, what I'm explaining, it all depends upon the application to application. Some people uses raw zone, history zone, curated zone. Some people uses bronze, silver, gold. It all depends.
Okay, fine.
But maintaining this zone is kind of a normal thing in any data engineering project.
Okay.
Right?
So PC, I have one question. So this in source we have raw data, and we are just that uploading that raw data in ADL as a brown zone. That's it.
Right.
We are just copying the data.
Yes, copying as
right?
it is.
And then we are refine as
Yes.
it is. Okay.
Right.
Then we are refining it more, and it is coming into a silver zone. Then we are refining it more. Then it's a golden zone. Right. And
Right.
after that, if we want, then we can do a RPT reporting.
Yes.
And
So
that's
this itself
right?
can be used for reporting, but still if you want to have more aggregated, more thing like direct tables, then you can have reporting layer also on top of it. Right, you're right.
So I have one more question. So in a situation that company saying that I want more refined data, more refined data, more refined data. Suppose we have raw data. Okay, in brown zone we have a raw data, and I have done some refinement, and again I have done some refinement, and suppose after gold I have again done some refinement. So what
there
is
won't be
that?
gold? Basically, it is the final layer. It's a final layer of aggregated data. Okay, so whatever the refinement you are doing between these two only. We here itself we are doing all the refinement. Okay, all the refinement you are doing on top of the silver layer only, silver data or raw data. But finally, when you pick up the data and aggregate, you store the data into the gold. After the gold, there is nothing. It's final destination. You just pick it up.
So basically, what we are doing is that we are actually doing the ADB Databricks function from brown to silver, and from silver to gold, we are just aggregating the data, and then we are reporting it.
Right.
Makes sense.
So from here to here, I'll create a notebook. and do some refinement and all. From here to here, again, I'll create a notebook in the Databricks. Okay, don't get scared by one terminology. These are all we'll be using going forward. Okay, notebook means it's just a web interface to write your code in the Databricks. So then what happens once you do all these things, we'll integrate this in the ADF. So from here to here, what happened? A activity I'm using to load the data. From here to here, what I'm using? Actually, I'm using the Databricks notebook. I'll call the Databricks notebook using one more activity. From here to what I'm doing, I'm calling one more Databricks notebook activity. So finally, I will combine all these things under again one more pipeline, ADF pipeline. That is the reason, apart from integration tool, ADF is also called orchestration tool, orchestrating all these things in a single place. Got it? I'm very poor in writing actually. That's reflecting here. Yeah.
Hello.
Yeah, please tell me.
So
Hari?
from source to from source to raw branch silver, we are using the copying like a Azure Data like storage, Azure storage, right?
Right.
After that, you said that from raw data factory. What about the? I mean, what is the data factory? Again, we are copying, or what is the time?
Sorry, did not get your question. From here to here, you copying the data.
No,
Okay.
That is the storage.
Right.
Azure Data lake.
Right.
Then again, you said that data factory in bottom.
No, data factory I'm using. Data factory is a tool which I'm using to copy the data from these sources to this raw layer, raw zone.
Okay, data factory tool.
Yeah, data factory is one of the tool, extraction tool I'm using here to get the data from here to here.
Okay.
Okay. Yeah. And here, yes. And one more thing. Here, what I told, from here to here, I'm loading the data. From here to here, I'm loading the data. I'm using Databricks, I said. Okay, it's not mandatory that each and every time using the data factory. No, sorry, Databricks, I said. It's not mandatory that each and every time using the Databricks. Sometimes I feel that I have less number of the data. I don't need to go for the Databricks itself. Then I will use same ADF. Okay, in the ADF we have data flow for transformation. I'll use the ADF itself here also. From here to here also I'll use ADF only. Sometimes once the data is coming over to here, sometimes what I'll do in the silver zone, I'm storing the data in the data lake. But sometimes I might go for the SQL Server database only for storing the data from here to here. Okay, again from storing here to here, I told Synapse database. Sometimes the people says that I don't need a Synapse database. I don't want to incur much cost. I'll go simple SQL Server database only because my data is less. I don't need to spend much cost on the Synapse. Then I'll go for the SQL only. Right? So everything, whatever we store, it all not limited to a particular technology, particular process. Okay, technology దీనికి ఇదే యూస్ చేయాలి, డేటా వేర్హౌసింగ్ కి సినాప్స్ యూస్ చేయాలి, డేటా తీసుకురావడానికి ఓన్లీ డేటా ఫ్యాక్టరీ యూస్ చేయాలి, ఫర్ ప్రాసెసింగ్ డేటా బ్రిక్స్ యూస్ చేయాలి. దెర్ ఇస్ నో సచ్ కండిషన్. Okay, so from the database, from the data, the amount of the data, okay, the level of transformations that you are doing, the budget of the customer, the flexibility of the client, these are all matters when you architect the technologies for this data loading across the zones. Got it? Andarki arthamainda?
Where you are using Azure Data notebooks, you are calling in ADF?
Yeah. So ADF, once you write the code in the data, all this across all these things, we'll call that notebook in the data factory, because data factory is a kind of wraps all this into single place. That is called orchestration tool. Getting? Does it answer your question?
Yes, please.
Yeah.
So the data is stored in SQL database. So how you can call that data using Synapse Studio?
So which case I'm saying? Which case you're saying?
Yeah, in the silver In the
In the
silver
silver,
zone.
in this example, one more example I give. I told there might be scenarios where I will store the data in the SQL Server database only. Again, from SQL Server database, I will refine. I might go for again one more SQL Server database, or I'll go for a Synapse database. It all depends. How do I go and what I choose.
Okay.
Okay, but it all depends. But most of the cases, we use the big data projects. So most of the cases, we'll go for the ADLS things, and here we'll go for the Synapse. And there are some projects from ADLS to from zone to zone. They might use even for the what do you call serverless SQL pool. They don't use Databricks itself because they says that the data is normal. I don't want to incur much cost. Then I might even consume the data using the serverless SQL pool in the Synapse. That we'll talk about it. It all depends, like what exactly tool you are using.
Okay.
Any more doubts? Sunil, you have any question?
Finally, we are storing all the once we have copied all the reporting data, then it will store in the ADF. Is it right?
Store in the ADF, you're saying?
Yeah.
No, ADF is a tool. ADF is a tool to load the data. Finally, in this example, I am using the Synapse dedicated SQL pool, which is nothing but a data warehouse. Synapse dedicated SQL pool. So, which is a data warehousing for the Azure. So, we are storing the data in the data warehouse database using the data factory or using the data bricks. Okay, data bricks, data factory, these are all for loading the data and writing the logic for your transformations and all. Okay, but where exactly you're storing, here I am storing in the data warehouse, that is dedicated SQL pool. Here I'm storing in the data lake. Right? So this is how the data. So what happens each and every time when I store the data from here, these are the sources. We have small sources. From here sources, we are getting the data using the data factory. And here, what I'm using here, I might use a data bricks or anything depending upon the technology I'll use. Sorry. So here I'm using the data bricks. Here also I'm using the data bricks. Finally, the data load will be done in the Synapse, dedicated SQL pool Synapse. Okay, there is a modern data warehouse created by the, introduced by the Microsoft. Okay, so this is how we do. Any doubts? How do we do in the? So we'll kind of try to implement these zones when we are done with the most of the technologies. Any more doubts? Yeah. So what is the big data? Let's quickly go over some of the previously discussed things. What is the big data? What is the big data? Because it's all about handling the big data in the modern data, right? So what is the big data?
Multiple sources having multiple format files.
Okay.
in huge basis.
Right. So when you have huge amount of the data, multiple sources, multiple formats, it's a big data. Right. You're right. Okay. And apart from this, I need to talk about one more thing before we end the session today. So there will be two types of the data whenever you deal with the data. Okay, of course, everything is a big data, everything is a data, everything is a different formats and all. So what are the different types? There will be two types. One is batch data and one is streaming data. Okay, so what is the batch data? So batch data is nothing but the data which is coming as batches at regular intervals. Okay, it's kind of doesn't change, it just resides in the source. We just take it as it is, like for every day, every month, or every 1 hour, like that we do. That is a batch data. Okay, we use a data factory to extract the batch data and all. But apart from batch data, there'll become something called streaming data. It's also called real-time data. So what is streaming data? Streaming data, the data which comes at the regular intervals, not exact regular intervals, it keeps on flows. What is stream? A flow, right? So the same way the data flows into regular intervals, as it keeps on coming. So we need to have the ability to capture it and store it and refine it and finally give it for the reporting. Okay, so what is the example? So when you get the streaming data, we use Event Hub, Stream Analytics, those technologies we use Kafka to process the streaming data. Okay, so this, what is the streaming data example? Suppose you have a bank, so you will perform series of transactions on the bank. Okay, so you cannot say that for this all bank data is there, I will wait till in the evening, then only I will get into my data warehouse, then only I will start analyzing the data. Okay, that doesn't make any sense, because bank transactions are very critical to analyze and do some error detections and all. So that is the reason we need to keep on we need to keep getting the data, we need to keep ingest the data into our environment. Okay, so that is also streaming data. What is the one more example of streaming data in the general terminology? So when you have this what do you call power distribution, when you have power generation, you keep on distribute the power from the location to your substation to all, right? These are also being monitored. So these are also streaming data, we need to analyze at regular intervals, streaming data, right? And one more thing is a what do you say, dams. In the dams, how much water is coming and all, that is also streaming data. And what is the example? Yeah, so in the automobile industry, the series of devices gets connected to the IoT data, and finally they assembles into a car or bike, then it comes to the end product. Then also the series of the data we need to capture, and we need to process and analyze it, because we cannot wait till the assembling completes. Otherwise, if there are any errors in between, then you will get a fault product. That is also called streaming data. So these are all called streaming data, batch data. There will be two types of data would be there. Okay, some projects handles only the batch data. Okay, some projects might have the batch data and streaming data both. Okay, so as far as I know, like sorry about myself, there is only one small project I handle streaming data, but most of the cases I deal with the batch data only. Okay, in critical projects like insurance, banking, definitely there will be a streaming data which you need to process, right? So this is about the different layers, different types of the data which we need to understand before we jumping into actual cloud or data engineering. Any notes? No doubts? That's great. Okay, no doubts. I'm going to stop recording.